I am Dr. T V Sundar, Associate Professor in the PG and Research Department of Physics of National College. In this demonstration experiment, I am going to explain you the use of the embedded systems, 32-bit microcontrollers with a software control for generating different pulse generation applications. Hello viewers, welcome to this demonstration video of the use of microcontrollers for pulse generation applications. Microcontrollers are embedded systems where they can be used for very many laboratory applications. So in this demonstration, I am going to explain how pulses of different frequencies can be generated using microcontrollers with software tweaking. In physics laboratories and electronic laboratories, pulses of different widths are often required, where the timing are usually controlled by the use of capacitors and resistors. But the microcontrollers actually help us in avoiding the use of different RC values simply by software control, that is by delaying, changing the delay loops. Pulses of different widths can be generated. I am going to demonstrate that application with the circuit arrangement. You look at the arrangement where the interface, the software interface, Energia is used to write the codings. Once that coding is generated, it can be transferred to the microcontroller. After that, using that optocoupler arrangement, pulses of different widths can be generated. For low pulses, pulse width generation, this can be observed from the voltmeter output itself. But when we go for high frequency pulse generation, our eye is not having that much of a resolution, so the output can be seen on the CRO screen. I shall display both these two options. First I go for low frequency pulse generation. First I am generating a square wave pulse having on time 1 second as well as off time 1 second, and I have configured a green LED. Just by blinking, looking at the blinking of the green LED, this can be analyzed. Now look at the voltmeter where the needle switches between 1.5 volts and 2.5 volts. Here I am optically coupling the output of the green LED with the help of a LDR. So this is the first example. Next, to generate another LED, another pulse, I have just changed the delay loop values, that is software control. Look at the pulse output varies. Now see the needle of the voltmeter where the pulse width change can be easily observed. If you need to go for high frequency pulses, we have to control the delay loops to very low values. So just I am giving 0.5 millisecond. But once this is done, to our eyes, the variation is not visible. This can be detected only with the help of a CRO. Look at the CRO screen. A pulse is having 1/3 duty cycle is generated. To change to some other value, I am just change the value in the codings. See the variation in the pulse width. Again, one more change I am effecting. Just 1/10 of the variation being, look at the change in the pulse width. So in this manner, without changing the hardware requirements, simply by controlling the microcontroller coding values, we can generate pulses of different frequencies. And this we have affected by making the switching time of a LED to blink at various time intervals, and by opto coupling the signals with the help of an LDR, we are generating the pulses.